Hey guys, we'll be going over the exam 2 solutions for SPECH. So yeah, let's get into it. Okay, question 1. For any integers, consider this statement. The contrapositive of this statement is, so to find the contrapositive, we just need to switch the two sides of the statement and then negate both sides. So the left side of the statement is going to be the negation of this, which is equal to m less than 5 and n less than 5. And the only option that has that is A. Sorry, not A, C. All right, now question 2. Consider this function, hybrid function. Which of the following statements is correct? Okay, so the top function here, what we can do is we can rewrite it, x minus 2, x plus 5, factorizing over x minus 2, and then these two cancel out, which just leaves us with x plus 5. So what that's gonna look like is the line of x plus 5, but then at the point 2, 7, so when you substitute 2, we get 7, there's going to be a hole. And then that hole, pause, is essentially filled by, pause, this part here, which essentially says at the point x equals 2, y equals 7. So that hole is essentially filled, pause, 2, 7. So that means that the function is continuous for all r, and there's no point of discontinuity. If this was a number, anything other than 7, then yes, there would be a point of discontinuity, but it is 7, so A is the correct answer. Question 3. This graph will have no turning points when. All right, so to do this, I'm going to go to our CAS. I'm going to define f of x as this function. X plus 1, x plus 1, x minus 4. And we're going to solve for its derivative, and it's going to equal to 0. F of x equals 0. And we get these two. And obviously there will be no turning points when the inside of the square root is less than 0. And that gives us negative 1 and 4. But then we have to also include negative 1 and 4, because when h is equal to negative 1, then these two are going to cancel, giving us 1 over x plus 4, or x minus 4. And obviously that has no turning points. And same when h is equal to 4. So C is the correct answer. All right, given that sine of x is equal to A, where x is in the fourth quadrant, then cos of x on 2 is equal to, okay? So from here, cos of x is equal to square root of 1 minus a squared, just using the Pythagorean identity. And it's positive because it's in the fourth quadrant. Cos is positive in the fourth quadrant. Okay, now we have cos of x on 2. To find this, we have to use the formula cos of x is equal to 2 cos squared of x on 2 minus 1. So this means that cos of x on 2 is equal to, well, when we solve it, we'll get the plus or minus square root of 1 minus a squared minus 1, plus 1 over 2. And now I have to decide which one plus or minus it is, and it is going to be minus. The reason being because since x is in between these two numbers, when we divide it by 2, it's going to be between 3 pi on 4 and pi. And where's this? That is in the second quadrant. And cos is negative in the second quadrant. So it's going to be A, which is the negative version of this. Question 5. The point 1 plus root 3i is represented. The point negative conjugate of z can be located by. Okay, so negative conjugate of z is going to be -1 plus root 3i. So if we look at that, it's going to be essentially go from here to here, which is a rotation of pi on 2 this way, which is anti-clockwise, I think. Yeah, so that's going to be p. Question 6, z equals 3 plus ki. A value of k that makes z squared, that expression, purely imaginary is. So yeah, we're just going to put that into the cas. 3 plus k I, and then ans squared plus 4 I ans plus 3. And this is purely imaginary when the real part is equal to 0. So k is equal to 2. All right, a solution to the differential equation can be found using. Okay, so to do this, we have to convert these two cosines back into just cos of x and sine of x. So that's going to be cos of x, cos of y, plus sine of x, sine of y. And then the cos of x plus y is cos of x, cos of y, plus sine of x, sine of y. These two cancel, leaving us with 2e to the x minus y sine of x sine of y. Or 2e to the x times 2 times e to the negative y. All right, and this is what dy dx is equal to. So when we put all the y's onto one side, we're going to get the integral of e to the y on sine of y dy. And on the right side, we have 2e to the x sine of x. Okay, so yeah, that's just c. Yep. Consider the differential equation. When Euler's method is applied, find the step size. Okay, for these questions, you could create like a formula in terms of h, set it equal to this value here, and then find h, but I can't really be bothered doing that. So I'm just going to test each value of these four. So what we're going to do is going to go Euler xy squared xy. And we're going to do the curly brackets. And then we're going to go from 0. And then let's let the step size equal 0.01. So x of 3 is equal to 0.03. Y of 1 is equal to 1, as said in the question. And then step size is 0.01. And that gives us a y3 value of this, which is obviously wrong. So we're going to try again with a step size of 0.02. Once again, wrong. So let's try 0.2. 0.6, 0.6, and 0.2. And that gives us 1.12653, 1.12658, which is close enough, I guess. So C is the answer there. Question 9, the length of the curve specified by x is equal to 1 minus cos t and t minus sine t is given by, so just using the formula, integral from 0 to pi of the square root of dx dt squared plus dy dt squared. So let's see what the square root of those two is equal to. Dx dt is equal to sine of t, so sine of x, I'll just write x squared, and dy dt is equal to 1 minus cos of x, so 1 minus cos of x squared. So that gives us the square root of 2 minus cos of t. And then, since that doesn't equal any of these, we're going to convert this into cos of t on 2. by going 2 minus 2, 2 cos squared of t on 2 minus 1, giving us 2 minus, well, actually it's going to be 4, and then minus 4 cos squared of t on 2. This 4 goes out, giving us 2, and then 1 minus cos squared of t on 2 is equal to sine of t on 2. So that gives us A. Okay, question 10. The curve defined by these parametric equations is rotated around the y-axis to form a solid of revolution. The area of this surface is, okay, so it's going to be 2 pi integral from 0 to k of x, since it's rotating about the y-axis, so x, 5t, square root of dx dt squared, which is actually 5 squared, which is 25, plus dy dt squared, plus 144. So that gives us 2 pi, 3, 0 to k of 5x square root of 169, giving us 65 k squared pi, which is A. Done. Okay, so now we have a velocity time graph. The initial velocity is 40 meters. How far in meters is the particle to the east of O 150 seconds later? So that's essentially this area minus this area. So yeah, we need to find this point. And to do that, we need to find the equation of this line, which we can do by finding the gradient first. So the gradient is negative 20 minus 40 over 100, negative 3 on 5, and then solve, and times x plus 40 is equal to 0. So this point is 200 on 3. Therefore, this area, this triangle is equal to half times base, 203, times height, 40. And then subtract the area of this triangle, which is half times base. The base is going to be 150 minus 200 on 3, multiplied by the height, which is 20. So that gives us 0.2, 0.5, 200 on 3, times 40, minus 0.5, 150 minus 200 on 3, 20, 500. All right, position x meters of a particle moving in a straight line is given by that. The acceleration of the particle when x is equal to k plus 1. Okay, so we just need to find what t is equal to when x is equal to k plus 1. So solve. K plus 1 is equal to e to the power of k minus 1 t. Solve for t. And we get that t is equal to this. Now we have to differentiate x twice to get the acceleration. That's going to give us k minus 1 squared e to the k minus 1 t. And we're going to substitute t is equal to this into there. And we get that is equal to that, which is b. All right, the angle between the vectors is the arc cosine of 13 on 21. Then the value of m is equal to, so a simple application of the formula. Magnitude of this is equal to 3. Magnitude of this is equal to m squared plus 36 plus 4, 40. The cosine of the angle is going to be 13 on 21. And this is equal to the dot product of these two, which is 4 minus m plus 12. Solve. 3 square root of 40 plus m squared times 13 on 21 is equal to 4 minus m plus 12, which means m is equal to 3. All right, consider the two vectors such that, blah, 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 a bunch of information. if the vector resolute of r in the direction of s is equal to this, then the scalar resolute of s in the direction of r is equal to, all right, so we need to find scalar resolute of s in the direction of r, so s dot r over the magnitude of r, and which is 9, so s dot r over 9. And I'm actually just going to guess that it's -2, just like educatedly, because this is equal to this over 9. So I'm kind of just going to guess that it's -2. But anyway, let's just do the working. All right, so r in the direction of s is equal to this, which is equal to -2s. So this means that r dot s over the magnitude of s squared is equal to -2, which means that r dot s is equal to -2 times 9, yep, which is -18, and then -18 or 9 is -2. So yeah, B is the correct answer. Okay, the position of a body is given by this, where t is measured in seconds. The motion of the body can be best described as moving along a parabolic path. Okay, so yep. So cos of t is equal to, cos of 2t is equal to 1 minus 2 sine squared of t. So this means that y is equal to 1 minus 2x squared. Therefore, immediately cross out b and c. And then we can see where it's, oh no, these have the same points. Returning to 0, 1 after pi seconds. Okay, so let's see what happens when we substitute t is equal to pi into here. So when t is equal to pi, x is equal to sine of pi, which is 0, and cos is equal to, y is equal to cos of 2 pi, which is 1. So at t equals pi, it should be at the point 0, 1, which aligns with the information given in C, because A says at t equals 2 pi, x is equal to 0, and y is equal to 1. Oh, but they both say the same thing. Oh. Reversing direction at 1. I'm pretty sure it's C, because it does return to pi. This is implying that it returns to 0, 1 for the first time after 2 pi seconds, but that's not true because it returns to 0, 1 after pi seconds for the first time. So I'm just going to go with C. I'm not going to think about that too much. So yeah, that's the repeat of the same page. Question 16, a particle has this position vector and another particle has this position vector, where t is between 0 and pi 2. The number of times the velocity of particle 1 is perpendicular to the position vector of r2 oh, okay, interesting. So the velocity of r1 is equal to the derivative, so negative sine of ti plus cos of tj plus 2 cos of 2t on square root sine of 2t. Okay, and when we dot product that to this, we should get 0. So that means that negative sine squared of t plus cos squared of t plus this times this plus cos of 2t has to equal 0. And we need to see how many solutions this has in the interval 0 to 2 pi. So solve cos of x squared minus sine of x squared plus cos of 2x is equal to 0. That's going to give us a general solution. So at the end, we'll just say between 0 and pi on 2. Please give me like once. Boom. Once. Does it have an exact solution? Just curious. It doesn't. Okay, great. Oh yeah, so that's it. Just double checking my CAS was in radians. Yep. All right, cool. Question 17, consider these following lines. The shortest distance between L1 and L2 is, okay, so since they're parallel, they are not skew lines, so we can't use the skew line formula. So what I want to do is I'm just going to choose a point on R1, which is 1, 3, 1, and find the shortest distance of this to the point negative 2 plus t, 1 plus t, and 3 plus t. All right, so yeah, so the distance between those two is going to be the magnitude of their difference. So square root of this minus this, t minus 3 squared plus t minus 2 squared plus t plus 2 squared. All right, square root of x minus 3 squared plus x minus 2 squared plus x plus 2 squared. And the minimum value is going to be at x equals 1, just by differentiating the inside. 6x minus 6 is equal to 0. So when substituting 1 into here, we get root 14, which is b. Question 18, the point of intersection of the line and the plane is, okay, so this line is equal to 1 minus 2t, 1 plus t, negative 2 plus 3t. And when we substitute that into here, we get the equation 3, 1 minus 2t minus 2, 1 plus t plus 4, negative 2 plus 3t is equal to 0. So solving that, 3, 1 minus 2x minus 2, 1 plus x plus 4, negative 2 plus 3x is equal to 0, not 0, 5, sorry, 5. Giving us x is equal to 3. Substituting x, or not x, t back into here, we get 1 minus 6, negative 5, so that's either A or D, and then 1 plus 3 is 4, so D has to be the answer. When conducting a hypothesis test, a type 2 error occurs when, so type 2 error is when we accept H0 when it's false. So accept or so null hypothesis is H0. So null hypothesis is not rejected when alternative hypothesis is true, A. Last multiple choice question. The masses of avocados in a crop are normally distributed. M, 200, 7.5. After an avocado is peeled, edible flesh, okay, so F, 0.7 times 200. My quick maths is not that good. Times 200, 140. 140. And then the standard deviation is 0.7 times 7.5, 5.25. 5.25. 4 avocados are randomly selected. Okay, so F1 plus F2 plus F3 plus F4, giving us 140 times 4, 560, and 5.25 times 2, 10.5. 10.5. 10.5. And the probability that this is greater than 570. So menu 552, lower bound 570, infinity 560, 10.5, 0.1705. Boom. All right, that's the multiple choice complete. I was going to do it all in the same video, but I'm currently busting and I really need to take a piss. So yeah, I'll do the extended response in a different video. Thank you for watching, and please correct me if I got anything wrong. I'm open to criticism. I'm not a bitch. So yeah, thank you so much. See you later.